All right. So, you know, with your philosophical leanings, I thought we'd really dive deep into this fascinating question of how groups make decisions when they don't all agree. I mean, it really gets to the heart of some big philosophical questions about how we go from individual beliefs to a collective choice.
Yeah, absolutely. It's like this amazing crossroads of practical decision making and some really deep theoretical stuff. We're talking about the mechanics of how collective will is formed, which touches on everything from the social contract to the legitimacy of political systems.
Yeah.
And I think you hit the nail on the head. How does a committee or even an entire nation arrive at good decisions when there's, real disagreement among the people?
Right. And those disagreements play out everywhere, from big political elections to figuring out where to go for dinner with friends. So to tackle this, we use these formal systems called voting methods.
Exactly. And the Stanford Encyclopedia of Philosophy has this great entry on voting methods, which is our main source for this deep dive. It lays out all these different systems we've come up with to take individual preferences and turn them into one collective outcome. What's really cool is that it brings together insights from all these different fields: math, philosophy, political science, economics, to really unpack the problem from every angle.
It's a real interdisciplinary thing, huh? So, obviously there's no one perfect way to vote, right? I mean, each method has its own strengths and weaknesses.
Yeah, for sure.
Yeah.
And that's where the philosophical stuff gets really interesting. I mean, you can take the exact same set of preferences from a group of voters and end up with completely different winners depending on which voting method you use. So that immediately makes you think, okay, which of these methods is actually the most fair or the most accurate representation of what people actually want?
That's what makes this whole topic so intriguing. And, our goal today isn't to say that one method is better than another. Instead, we're going to try to map out this whole landscape of voting methods, see how they compare to each other, and uncover some of those head-scratching paradoxes that pop up when you try to translate individual desires into a single choice for everyone.
Totally. And I mean, you've probably seen debates about electoral reform and stuff like that. What we're doing today is going way deeper than that, into the actual theory behind how these systems work, or sometimes don't work the way we think they should. So, to kick things off, why don't we start with a voting method that, everyone's pretty familiar with: plurality rule.
Oh, yeah. First past the post, the one where whoever gets the most votes wins. Seems pretty straightforward.
Right. Super simple. But here's the catch. Plurality rule can actually lead to something called a Condorcet loser winning.
A Condorcet loser? What's that?
So a Condorcet loser is basically someone who would lose in a head-to-head contest against every other candidate, even if they somehow managed to get the most votes overall.
Wait, so you're telling me someone could win an election but actually be the least preferred candidate if you compared them to each other candidate one-on-one?
Exactly. And the encyclopedia actually gives this perfect example to illustrate it.
Yeah.
Let's say we have 3 candidates, A, B, and C, and 21 voters. One voter ranks them A, B, C, then 7 voters have A, C, D, another 7 have B, C, A, and the last 6 go C, B, A.
Okay. Got it. 3 candidates, 21 voters, a bunch of different preference rankings.
Right. Now, if we use plurality rule, where everyone just votes for their top choice, candidate A gets 8 votes, B gets 7, and C gets 6. So A wins, right?
Yeah, A's the winner. Clear plurality.
But here's where it gets interesting. If we just look at B versus A, 13 voters prefer B over A. That's the 7 who ranks BCA, plus the 6 who rank CBA. And only 8 prefer A, those who put A first. So to head-to-head, B beats A.
Wow. Okay, so A wins overall but loses to B directly. Interesting.
And it gets worse for A. Against C, A loses even harder 20-1. Basically, everyone except that one voter who put A first prefers C over A. So even though A got the most votes overall, A is actually the Condorcet loser. A would lose to both B and C if they went head-to-head.
So the candidate who seems like the winner based purely on first-place votes could actually be the least popular overall. That's kind of wild.
It is, right. And the encyclopedia points out how this shows that just focusing on who people put first doesn't really tell the whole story, doesn't account for how much people dislike certain candidates or how spread out the support is.
It's like the plurality ranking says A is ahead of B and C, but when you look at who would actually win in a head-to-head matchup, the majority prefers C, then B, and then A. It completely flips the order. Yeah. And that raises a big philosophical question. Can we really say a system is fair or representative if it can elect someone who most people would actually vote against in a one-on-one?
Right, exactly. And that brings us to another type of voting rule called quota rule. This is where you need to get a certain percentage of the votes to win a quota. So Majority rule, where you need more than 50%, is a type of quota rule. And then there's unanimity rule, where everyone has to agree, which is like a super strict quota.
Okay, so instead of just needing the most votes, you need to hit a certain threshold. Makes sense. But what are some of the, philosophical issues with quota rules?
Well, the main problem, especially with majority rule when you have more than two candidates, is that sometimes no one actually gets enough votes to reach that quota. Like, remember our three-candidate example? No one got more than 50% of the first-place votes. So under a pure majority rule, there wouldn't be a winner.
So even though everyone voted and expressed their preferences, the system might not be able to actually make a decision.
Right, which could be a problem if you need to, actually take action based on the vote.
For sure. So how do we get around that?
Well, this is where things get a bit more complex, and we move into the realm of ranking methods. These methods try to take into account more than just your top choice. They consider your whole ranking of the candidates from most preferred to least preferred.
Okay, so instead of just saying who you like best, you're giving a more nuanced view of how you feel about all the candidates.
Exactly. And one of the most famous ranking methods is the Borda count.
I've heard of that one. It's the one where you get points based on where each candidate ranks on your ballot.
Exactly. So if you have 5 candidates, the candidate you ranked first gets 4 points, the one you ranked second gets 3 points, and so on. And the candidate with the most points at the end wins.
Okay, so let's try that with our 3-candidate example. What would the Borda scores be, and who would win?
Okay, so if we crunch the numbers, A actually only gets 24 points. B gets 44 points, a lot more, and C gets 38. So under the Borda count, B would be the winner.
Interesting. So we get a different winner than plurality rule, where A won. And the encyclopedia talks about how this difference highlights this big historical debate between Borda, the guy who came up with the Borda count, and Condorcet, the guy who came up with the Condorcet criterion.
Yeah, it's a classic debate in voting theory. Borda's method looks at the whole picture, how you rank all the candidates, while Condorcet's approach focuses more on those head-to-head comparisons.
So different philosophies about what makes a good voting system playing out in these different methods.
For sure. And the Borda count is actually just one example of a broader category called scoring rules. A scoring rule is any method where you assign points to each ranking, like first place, second place, and so on, and then add up those points to get a total score for each candidate. Plurality rule is technically a scoring rule too, just a really simple one where you only get a point for first place.
Okay, so Borda count is a type of scoring rule, but there are others too.
Right. Another one that's pretty interesting is called K approval voting. In this one, you get to pick your top K candidates, like your top 2 or your top 3, and they each get a point.
Interesting. Let's try that with the 4-candidate example from the encyclopedia. They have 2 voters with ADBC, another 2 with BDAC, and 1 with CABD. So what are the winners for different values of K?
Okay, so for 1 approval, which is just like plurality rule, we have a tie between A and B, both with 2 votes. But for 2 approval, D actually wins, getting 4 votes total. And then for 3 approval, it's a tie again, this time between A and B.
So depending on how many candidates you're allowed to approve of, the winner can change. And the encyclopedia also mentions that the Condorcet winner in this case is A, but A doesn't always win under K approval. So again, we're seeing that different methods can give you different winners, even when there's a clear Condorcet winner.
Exactly. Now let's shift gears a bit and talk about multi-stage methods. These are methods that have multiple rounds of voting, kind of like a tournament where you eliminate candidates until you get to a final winner.
Oh, yeah, like plurality with runoff, which is used in a lot of elections.
Exactly. So in plurality with runoff, you have a first round of voting, just like regular plurality rule.
Okay.
But if no one gets a majority of the votes, then the top 2 candidates go head-to-head in a runoff election.
Makes sense. It seems like a good way to make sure that the winner actually has support from more than just a small sliver of the voters.
It can be, but it also introduces some new wrinkles. There's this example in the encyclopedia where one candidate, A, wins under plurality with runoff, but then they introduce this other method called the Hare rule, also known as ranked choice voting or instant runoff.
Oh, yeah. Ranked choice voting has gotten really popular lately. How does that one work?
So in the Hare rule, voters rank all the candidates from their most preferred to least preferred. If one candidate gets a majority of first-place votes, they win outright. But if not, then the candidate with the fewest first-place votes gets eliminated, and the voters who chose that candidate get their votes redistributed to their second choice. And this keeps happening until someone gets a majority.
So it's like a series of runoffs based on everyone's initial ranking.
Right. And in that example from the encyclopedia, where A won under plurality with runoff, it turns out that D actually wins under the Hare rule.
Wow, so same voters, same preferences, but a different winner depending on the method.
Exactly. It shows how much the outcome can be influenced by which method you use. And then there's another multi-stage method called the Coons rule.
How is that one different?
So instead of eliminating the candidate with the fewest first-place votes, the Coons rule eliminates the candidate who is ranked last by the most voters. So it's like trying to find the candidate who has the most people strongly opposed to them.
Interesting. So what happens in our example if we use the Coombs rule?
With the Coombs rule, B ends up winning. A gets eliminated in the first round because A was ranked last by the most voters. And then after the votes get redistributed, B ends up with a majority.
So we've seen 3 different winners, A, D, and B, all from the same set of voter preferences, just by using 3 different multi-stage methods. That's pretty mind-blowing.
It is, right. It really highlights the point that the choice of voting method is not just some technical detail. It can have a huge impact on who actually wins.
For sure. Okay, so we've talked about methods based on ranking candidates, but what about methods where you actually give each candidate a score or a grade?
Yeah, those are called voting by grading methods. One simple version is negative voting, where you can either vote for a candidate or against a candidate.
Okay, so you're basically saying whether you support or oppose each candidate.
Right. And then there's approval voting, where you can vote for as many candidates as you want, as long as you approve of them.
I like that one. It seems like it gives voters more flexibility to express their preferences.
It does. And the encyclopedia says that approval voting could actually lead to the Condorcet winner being elected, if there is one. But it's not guaranteed.
So it's better than plurality rule in that sense, but it doesn't completely solve the Condorcet loser problem.
Right. And then you have methods that use a more defined grading language, like a set of grades or scores that you can give to each candidate. So you have cumulative voting, where you get a certain number of points to distribute among the candidates however you like. And then there's score voting, where you give each candidate a score on a numerical scale, and the winner is the one with the highest average score.
And then there's majority judgment, which the encyclopedia says uses the median grade instead of the mean. What's the thinking behind that?
So the idea of majority judgment is that using the median, which is the middle grade when you line them all up, encourages voters to be more honest about their opinions. Like, if you know your honest grade is probably going to be close to the median anyway, you're less likely to try to game this system by giving a candidate a really high or really low grade.
Makes sense. And the encyclopedia gives this example where score voting, based on the average, and majority judgment, based on the median, actually pick different winners from the same set of grades.
Exactly. And there's a lot of debate about which approach is actually better, whether you should use the average grade or the median grade to decide the winner.
Seems like every method has its pros and cons.
That's the thing, right? There's no perfect system. And we haven't even touched on some of the newer ideas, like quadratic voting, where you can buy more votes, but they get more expensive the more you buy. And then there's liquid democracy, where you can choose to either vote yourself or delegate your vote to someone else you trust.
Wow. Okay, so many different ways to vote. But how do we even begin to compare all these methods and decide which one is the best for a particular situation?
Well, the encyclopedia lays out some key criteria to consider. There are practical considerations, like how easy is it to understand the method and actually use it. Then there are behavioral considerations, like how do these different methods actually affect the way people vote in real life? And then you have to think about how much information you need from voters. Do they just need to pick one candidate, or do they need to rank all of them?
And then there's the really theoretical stuff, like those paradoxes you were talking about and those axiomatic characterizations, which I think you mentioned earlier.
Right. So with axiomatic characterizations, you're basically trying to define voting methods by the properties they have. Like, is it anonymous, meaning every voter is treated the same? Is it neutral, meaning every candidate is treated the same? And then you have things like the Condorcet criterion, which we talked about before, and May's theorem, which is a famous result about majority rule.
And then there are those paradoxes which show how even voting systems that seem fair on the surface can sometimes lead to really strange and unexpected results. Like we already talked about Condorcet's paradox, where you can have a cycle of preferences where A beats B, B beats C, and C beats A.
Exactly. And that just shows how tricky it can be to try to combine individual preferences into a collective decision. And, even though each individual voter might have a clear preference order, when you put all those preferences together, you might not end up with a clear winner, or you might end up with a winner who is not actually the most preferred candidate overall.
It's like the idea of a will of the people can start to get really fuzzy when you look at it closely.
For sure. And that brings us to another class of paradoxes called failures of monotonicity. Basically, monotonicity means that if you make a candidate stronger, like if more people rank them higher, then their chances of winning shouldn't go down.
That makes sense, but you're saying that some voting methods actually violate that principle.
Yeah, unfortunately. Like with plurality with runoff, there's actually a scenario where a candidate can win, and then if some voters decide to rank that candidate even higher, that candidate ends up losing. It's crazy.
How is that even possible?
So, with plurality, with runoff, it can happen because changing the rankings can change who makes it into the runoff in the first place. So, like, you might think you're helping a candidate by ranking them higher, but you might actually be hurting them by changing who they have to face in the final round.
So even trying to help your favorite candidate can backfire in some voting systems?
Right. And then there are paradoxes related to changes in the number of voters called variable population paradoxes. One of the most troubling ones is called the no-show paradox.
What's that one about?
So the no-show paradox is basically this. Sometimes voters who vote for the winning candidate would have actually been better off if they hadn't voted at all.
Wait, so you're saying that in some voting systems, it's actually better to not vote at all? That's crazy.
It is, right. It undermines this whole idea that voting is always a good thing. And the encyclopedia gives this example with plurality, with runoff, where a candidate, C, wins with 11 voters. But if two of those voters hadn't shown up, another candidate, B, would have won, and those two voters actually preferred B over C. So they hurt their own chances by voting.
So even participating in the election can backfire in some cases.
Yeah, it's a really weird result. And then there's another paradox called the multiple districts paradox.
Okay, what's that one about?
So this one happens when you have a candidate who wins in every single district, but then loses the overall election when you combine the results from all the districts.
That seems like it could lead to some serious problems with representation, especially in a country with a lot of different regions.
Definitely. And the encyclopedia gives an example with the Kuhn's rule, where candidate B wins in both districts, but then A wins overall when you combine the results. It's kind of like a voting version of Simpson's paradox, which is this statistical thing where a trend can appear in different groups of data, but then disappear or reverse when you combine all the data together.
It seems like there are all these hidden complexities in trying to aggregate individual preferences in a fair and consistent way.
Totally. And then there's another paradox related to when you have multiple propositions on a ballot, like in a referendum.
Oh, like when you have multiple yes-no questions.
Right. So the encyclopedia gives this example with 13 voters voting on 3 propositions, and no wins on each one individually. But when you look at how each voter voted on all 3 propositions together, no one actually voted no on all 3.
So even though no won each individual question, it wasn't like everyone was united in voting no across the board.
Exactly. It shows how the way we aggregate votes can sometimes lead to an outcome that doesn't really reflect the full complexity of what people actually want.
Wow, so many paradoxes. It's making my head spin a little bit.
Yeah, it's a lot to take in. But we've only scratched the surface of voting theory. There's a lot more to explore, like the whole issue of strategic voting, where people might try to game the system by not voting honestly. And then there's this really interesting area called computational social choice, which uses ideas from computer science to study voting.
This has been a super interesting deep dive, and it's really made me think about all the different ways we can vote and how those choices actually matter.
Totally. And, as a philosopher, I think this whole area really makes you question some fundamental assumptions about democracy, fairness, and even truth itself. Like, if every voting method has its own flaws, can we ever truly capture the will of the people in a perfect way?
Yeah, big questions. And it makes me wonder about the voting systems we use in our own lives, not just in political elections, but in any group decision, like choosing a movie to watch or deciding where to go on vacation.
Exactly. It makes you think about how these systems work and how they might be influencing the decisions we make without us even realizing it.
Food for thought. Thanks for guiding me through this complex and fascinating topic.
You got it. It's been fun.